Hello everyone, so today I wanted to make an introductory video to synthesis. I know that when I began synthesis it was a lot and at the same time, and I know how it feels, and so I wanted to give you guys some tools and tips and tricks so that way you guys can at least approach it in a better way and see it in a different lens. And I'll try to give you different tools so that way you can see what works for you and then approach it that way. Again, everyone approaches it in a different way, and so I just want to expose you at least to different ways that you can approach it, and so then you will find the one that works best for you, and that'll give you a leg up whenever you are doing synthesis. Now, before I get into synthesis, what is synthesis and everything, I want to make a huge emphasis that you guys need to know your mechanisms. Even though in synthesis you are not going to be showing your mechanisms, you need to know them inside out, because, and I can't stress that enough, because if you don't know your mechanisms, you're not going to know how to predict the product, and you're not going to know how to go from A to B to C to D, okay? Now, I want to also clarify that there are many ways for synthesis. There's not only one way to make a product. There are many ways to make a product. You can, for example, if I want to do an alcohol, maybe I can do an SN2, or maybe I could do a hydroboration. It's not that it's only going to be in one way that you're going to do the reaction. But the thing is that if you don't know your mechanism, you're not going to know what that product is going to produce and how to build off from there, if that makes sense. If you don't know what hydroboration is, if you don't know what oxymercuration is, you don't know what SN2 is, I have videos on those, so you can go check that out and then come back to this video. So let's get into the actual question of what is synthesis. So synthesis is make this product. So what happens with synthesis is that sometimes professors will be like, they'll give you constraints or they won't. And what are constraints? So constraints would be like, I want you to make this product, but your starting material has to be 2 carbons. I want you to make this product, but you cannot use these chemicals. You can only use these chemicals. I want you to make this product, but it needs to be from an alkene. I want you to make this product, but you have to use this reaction. Okay, so those would be considered constraints, and that's just part of what it is. Sometimes they'll just say make this product, and they won't give you any constraints, and that's better. That's sometimes like easier, because maybe it'll be 1 or 2 steps, not always, right? But usually it's less steps than if they give you an actual starting material that you have to use and then build your way up from there. Okay, so these are the questions that you guys should have in mind when you are doing synthesis. Things to keep in mind. What is the starting material? What nucleophile can I use? What reactions can I use? What are the constraints? So what is the starting material? Are they giving you a starting material? Are they saying you need to begin from 2 carbons? You need to begin from this alkene? You need to begin from whatever? Are they giving you that? What nucleophile can I use? Let's say they're not giving me a starting material. Let's just say they're just saying make this product. Okay, looking at the alcohol that I have, the example that I have, I could say, oh, okay, I could have a hydroxide and I can have an SN2 reaction and that can make that synthesis. See, that's one step. Again, which reactions can I use? Like I said, the SN2. Or you could say like, not for this example, but let's say you have an E1 or an E2 or something. I mean, you could technically do a E2, I'll get into that, but you could do an E2 and then do a hydroboration. But what reactions can you use? What have you learned that you can use to make that product? And again, what are the constraints? Do you have any constraints? Do you have any limitations? Now for strategies. You can work forwards, you can work backwards, or you can do cutting. So I see that sometimes students will do the working backwards more than the working forwards, because sometimes when you're working forwards, you have to think way ahead of like, okay, I would have to do this and this and this and this, and then I will get to that product. Versus working backwards, you kind of see it one step at a time. So sometimes students like that more. Again, there's nothing against you working forwards or working backwards or doing cutting. It's whatever makes most sense in your brain, and sometimes too it depends on the actual problem that you have. So let's go into it. What's working forwards? So let's say I have this bromine. So technically, like I said, I could do a hydroxide and I can make an SN2 reaction. That would be one step, one and done. But for the sake of giving you more examples, I could say, okay, I have this bromine. What if I do a DBU, I make my alkene, and then from there I do a hydroboration. So that would be working forwards. Versus working backwards would be like, okay, I have my alcohol. Where does this alcohol have to come from? Well, I would have to come from an alkene, and then I could do a hydroboration to make that alcohol. So, okay, let's say I have an alkene. Okay. And then what would I do to produce an alkene? Well, I would have to do an E2 in this reaction. So that way I would produce my alkene. See? So then you work backwards until you have done whatever you needed to do, right? Now, let's go into what is cutting. So cutting would be this. I'm going to cut the molecule, and I would imagine what I have there. So let's say I have an SN2. Again, I have it on the screen. Let's say I have a hydroxide. The hydroxide is going to go attack the carbon, and then the bromine is going to leave. Great. I would have my alcohol that I have for the example. Okay, another example. Let's say I cut this molecule, and then I'm going to have my acetylide, and I'm going to have my 1-bromo-propane. Okay, again, I could do another SN2 reaction and have my product. Again, it's not that it's always going to be SN2, right? I did it for the sake of the video to keep it like shorter and show you guys. But yes, you can have different reactions, not always SN2. It could be an E1, it could be an E2, it could be SN1. It could be different reactions. Again, you could do halogenation, you could do hydroboration, you could do oxymercuration. Again, if those terms are not familiar to you, I highly recommend to go watch those videos, learn those mechanisms, so that way you will have the best chance possible to succeed in OChem and specifically in synthesis. My last piece of advice is that if synthesis is very hard for you, I understand, but I would highly recommend that you grab, let's say, an alkene, and you do all those different reactions. If I have this alkene, what would a hydroboration produce? If I have an alkene, what would oxymercuration produce? What would a halogenation produce? What would a halohydrogen produce? What would a whatever reaction produce? And go from there. Another thing I want to say is practice for friends if you have people in your classmates that you can practice with. And know that, like I said in the beginning, there's not one way to synthesis. There are many ways to make molecules. Now, sometimes you will be wrong. Sometimes, not always, but sometimes. For example, if I have an alkyne, right, and then I use H2PDC, I'm going to go all the way to an alkane. I'm not going to go to an alkene. So that would be an example of you being wrong if you're saying, oh, I can use H2PDC on this alkyne and make an alkene. That doesn't happen. It goes all the way to the alkane. So keep those things in mind as well, and how the reaction works, and again, what it produces. So that way you will, succeed in synthesis. Again, this content takes time to create, so please like, follow, share, comment. Let me know if you guys want me to show you any specific reactions or mechanisms or questions about organic chemistry in general, and I'll be more than happy to help. Lastly, I want to say that I am going to make another synthesis video with way more examples. This was more of an introductory video to kind of like introduce you to the topic and help you guys like know what you're getting into in a way. And again, happy studying. Good luck on your exams or finals or whatever you have coming up. And thanks again for watching.